On this video, we're going to look at polyatomic ions and we're going to see how to write the formula given the name. Polyatomic ions are a group of atoms combined covalently and can be charged positively or negatively. We're going to see covalent bonding when we do chemical bonding. Below is a table containing some important polyatomic ions. You should note that when oxygen is present, the names will end in ATE or ITE. So how do you know when the name will end in ATE or ITE? If you have two ions containing the same ionic charge, take for example SO3 2- and SO4 2-, but they have a different number of oxygen atoms, the ion with one or more atom will end on ATE. That is why sulfate ends in ATE, because it has one more oxygen atom compared to SO3 2-, and the other one, which is SO3 2-, will end on ITE. That is why the one containing 3 oxygen atoms is named sulfide, and then the one containing 4 oxygen atoms is named sulfate. So that's how you know when to end your name in ATE or ITE if you have oxygen in your compound, in your polyatomic ion. And this applies in NO2- and NO3- as well. We have nitrite and nitrate. Also in hydrogen sulfide and hydrogen sulfate, we have HSO3- and HSO4-. So you should remember this and you should know this. And this is the table showing the correct formula and name for some ionic compounds. You remember that the name ends on IDE if the anion is monoatomic. So if it's a monoatomic anion, the name will end in IDE. The name will also end in ATE or ITE if oxygen is present, and I told you how you see when it's going to end in ATE or ITE. The things you should note are that compounds with oxygen are called oxides. So all compounds with oxygen, they're called oxides. Acids have one or more hydrogen atoms. You should also know that. So all acids, they contain hydrogen. Your hydrochloric acid, your sulfuric acid, your nitric acid, all acids, they have hydrogen atoms. The hydrogen atom is written first in the above and in other compounds of hydrogen with oxygen, sulfur, and the halogens. Otherwise, the H is written last. So if you have a compound containing hydrogen and oxygen, the hydrogen will be written first. Hydrogen and sulfur, your hydrogen will be written first. Hydrogen and all the halogens are your group 7 elements. So all your group 7 elements and hydrogen, your hydrogen is written first. Otherwise, your hydrogen is written last. Hydroxides contain the anion OH-. They are usually strong bases. Compounds with a S2- ion are called sulfides. Remember, S2- is an anion, so the name has to end in IDE. SO3 2- ion are called sulfides. You know why that is. It is because we have the SO4 2- ion, which is a sulfate. So the sulfide has to end in ITE because it has one less oxygen atom compared to the sulfate. So how do you write the formula if you're giving the name? We have rules for determining the formula of compounds. So first, you write the cation, which is the positive charge, and then followed by the anion, which is the negative charge. The number of positive charges and negative charges should be equal and add up to 0 to form a neutral compound. Because remember, I told you that a neutral compound should have the same number of positive charges and negative charges. So if the charges of the two combining atoms add up to 0, then you are fine. They are combining in a 1:1 ratio. If they do not add up to 0, one or both ions must be increased so that the net charge is 0. We're going to see this on the next examples that we're going to. So example number 1, we have calcium oxide. How do you write the formula for calcium oxide? First, we need to look at the valencies. So the valency for calcium is +2 and for oxygen is -2. What does this mean? It means that the charges do add up to 0. So these two, they combine in a 1-to-1 ratio. So the formula can therefore be written as CaO. What about sodium oxide? We know that the valency for sodium is +1 and oxygen is -2. So these two, the charges do not add up to 0. So what are we going to do? We use the crossover method for this. So we need 2 sodium ions and we need 1 oxygen ion, because we need to balance this so that we get a neutral compound. So then we use the crossover method and we're gonna get Na2O after the crossover method. So basically what you do is you take the charge for oxygen and give it to sodium, and you take the charge for sodium and you give it to oxygen, so that you have 2 sodium ions and 1 oxygen ion. So then you get a total charge of 0. Another example is aluminium oxide. So aluminium oxide has a valency of +3, and aluminium has a valency of +3 and oxygen has a valency of -2. The charges do not add up to 0 again, so we use the crossover method. So we will need 2 aluminium ions and 3 oxygen ions, so that we get +6 and -6, which will add up to 0. So our formula will be Al2O3. And then we have copper 2 chloride. Remember, I told you that many transition metals have to have the Roman numerals written in brackets after the metal name, because you need to know what kind of transitional metal you're dealing with. So here we're dealing with copper 2. So it has a valency of 2+, and Cl has a valency of -1. So again, the charges do not add up to 0, so we use the crossover method. So we're gonna need 2 chlorine ions and 1 copper ion. So the formula will be CuCl2. How do we use prefixes in names? So some compounds are covalent and form small molecules. Again, you're gonna understand covalent bonding as soon as we start chemical bonding. The formulae of such compounds include subscripts to show the ratio of atoms in the compound. When writing names for these compounds, we use the prefixes mon for 1, di or bi for 2, tri for 3, tetra for 4, pent for 5, and hex for 6. So examples are carbon monoxide. The mon tells us that we only have 1 oxygen. Then we have carbon dioxide. The di tells us that we have 2 oxygens in carbon dioxide. SO3, sulfur trioxide, tells us that tri, we have 3 oxygens. Carbon bisulfide tells us that we have 2 sulfur atoms in this compound. Vanadium pentoxide tells us that we have 5 oxygen atoms in this compound. So as you can see, we do not write the prefixes for the compounds for the atoms that we start with in the compound, like for carbon, like for vanadium, for example. We didn't say divanadium pentoxide, we just said vanadium pentoxide. So we use these prefixes for the anions, so as to say. So we use this for the anions, for, yes, the anions. Okay, that is it for this video. On the next video, we'll start looking at non-metal, metalloids, and metals.